Good and bad news for you. Bad news is you will probably be late for lunch. I'm sorry for that. Good news is I'm not trying to do this in Dutch, so I'll stick to English. My Dutch is limited to us to believe. Then goedemorgen, and this was probably awfully pronounced anyway. So sorry, I'll go ahead in English. So I'll talk about managing and monitoring RouterOS today. And I've actually had a similar presentation on the huge European user meeting in Vienna a few weeks ago. But if any of you have seen that one, I'll slip in a few extra slides, so it's not exactly the same one. And I'll try to hurry so you're not that late for lunch. The agenda is a very, very short company introduction. The big picture of network operation. We'll have a look at management approaches and management tools. We'll see ways for network monitoring, and the last part will be about monitoring events on your RouterOS devices. FMS Internetservice is based in Germany, and we're a value-added distributor. That means next to classical distribution with an own warehouse and own stock keeping, we offer lots of trainings, consulting and support. We actually try to have knowledge about all the products that we're offering so that our customers have the choice if they need any extra services. The company was founded in the late 90s, and by today we have 11 employees and are located in the southern part of Germany. We have an in-house training facility, and we're proud to offer all Mikrotik certification levels, including the new security training. We have two pretty early trainers with trainer numbers of 11 and 23, and we're the first MTCSA certified German distributor. So you see, we really try to keep in touch and be up to date. So the big picture of network operation on the next few slides, and maybe a few words why I'm picking this topic. The reason for that is that we see more and more complex projects where customers would like to use Mikrotik, face problems in having the management and monitoring facility that they really need. There are IoT projects, for example, with thousands of devices, and such customers will come with very specific needs. And it's it's important for us as a distributor and you as Mikrotik service people or companies to offer your customers the possibility to finally use Mikrotik. The challenges today is that networks altogether are growing, so you have a growing number of devices. You will see more and more critical services being deployed. We have higher bandwidth, that means more packets are being sent through the network, which makes it more complicated to analyze it. And we have more heavy interconnection of sites when you're talking about enterprise networks. So altogether, the networks become larger, they're more complex, and on the other hand, you're required to have higher availability and very efficient security. So operation is a big topic, and operation involves different tasks like keeping inventory, that is knowing what devices you really deploy on your network, manage your devices, the first configuration, but also to adapt the configuration during the life cycle of your products to the changing needs. Maintenance, of course, like firmware upgrades or backups. Monitoring to see how your devices perform and to see if there are any bottlenecks upcoming. And of course, debugging at the end of the day if you're facing any problems. Luckily, Mikrotik is also already offering many tools in RouterOS, and I don't want to talk about each of them. But there are two slides as a reference if you want to look at it later on. And even if you work with Mikrotik for long, I'm sure you will find something that you never looked into. For example, TR-069 is a provisioning protocol used by internet service providers, which hasn't been in Mikrotik RouterOS that long. Or working with SSH keys, for example, is a pretty handy feature. And there are things like torch or the possibility to mirror traffic from your switch chip to do intrusion detection, or traffic flow or net flow, for example. So it's definitely worth to check out the features that you already have built into RouterOS. When we talk about management, it's always a trade-off between security and convenience. Considerations for a management approach will need to check for security, for convenience, as I already said, but management also has to be pretty efficient, so your staff can solve problems fast if they arise and don't have to start hours of work before they actually can work on the problem. Common management approaches pretty often use a separation of management and user traffic. There are things like management VLANs, for example, that all of you will probably know. But also PPPoE is an approach of tunneling user payload across the internet service provider's network. So the client's packets will enter at their CPE, they leave the tunnel at the access concentrator, and the client is not able to see all the equipment in your backbone in between. The other way around would be the approach to use VPNs for management, so you tunnel your management traffic through a payload network. When we talk about management, central tools are pretty important, especially for huge networks. And I want to point out that there are 3 tools available from Mikrotik directly that I'm not going to talk about today, but they should be named. One of them is the Dude. That's Mikrotik's network monitoring system. And I believe there's a Dude presentation later today, so you have the possibility to check that out. Then there's Capsman. Capsman is Mikrotik's Wi-Fi controller. And in local forwarding mode, Capsman is actually offering a separation of management and user traffic already, as Capsman will enable you, or Capsman will build automatic UDP tunnels from the access point to the manager, and the management of the access point will happen through this UDP tunnel, while user traffic in local forwarding mode will be released to the network from the access point directly. And then there's User Manager, which is not necessarily a management tool, but as RouterOS allows you to use local users or to configure local users on a radio server, and User Manager is a radio server, you can use User Manager to have central RouterOS accounts, and that will add up to security, as you can change your RouterOS administrator account, for example, or password centrally. So the examples I really want to look into with you are Roamon, CLI and scripting, and to see how you can integrate third-party tools, and how to build custom-tailored management systems by using the API. Who's actually using Roamon? Okay, very few. Either you're not listening or just very few people are using it. Roamon is a pretty interesting tool which is simplifying discovery and access of devices in your network. Roamon is called the Router Management Overlay Network, and it's a proprietary Mikrotik solution. It helps you with device discovery and device access. It's working layer 2 and layer 3 networks, so without layer 3 routing being in place, and it has direct Winbox support. To understand why you don't need layer 3 routing is, the reason for that is that you really have an overlay network, as it's been shown here. So Roamon is building automatically and without you doing anything, a virtual network for management on top of the real or visible network. When you see it's offering discovery and layer 2 access, there's something else coming in mind, of course, and that's MNDP, Mikrotik's Network Discovery Protocol, and Mac Winbox. So it's interesting to see what are the differences between MNDP and Roamon. And here's a short comparison. MNDP is using existing networks, while Roamon creates its own overlay network. MNDP is compatible with CDP, this is Cisco Discovery Protocol, and LLDP, while Roamon is Mikrotik proprietary and only working with Mikrotik devices. MNDP is limited to the layer 2 broadcast domain, and that's probably the most important difference, while Roamon will work across router boundaries. Both of them are integrated into Winbox, so you can use layer 2 discovery with MNDP, and we'll see how Roamon is integrated into Winbox later on. There's one pretty important point. This is Roamon will only work on Ethernet-like interfaces like Ethernet, Wi-Fi interfaces, Ethernet over IP, or VLANs. So I'll try to slow down a bit now. I hope I saved some time. Here's an example for local device discovery across routers. So from left to right, we have the operator's laptop, and then we have 3 IP subnets divided by 2 routers, and there are 2 access points in each subnet. At the bottom here, you can see how far MNDP will get you. So if you do a discovery, a neighbor discovery with your Winbox, you will see 2 access points and 1 router, as these 3 devices are within your layer 2 broadcast domain. If you use Roamon in contrast, you will see all the devices. Your laptop can connect to one of the routers or one of the devices and use that as a Roamon agent. And from there on, you can see all the devices in your network, even crossing router boundaries. So that way, an operator has the ability, if Roamon is enabled, to see all the devices in his network. To make that work, there's not much to do. You have to enable Roamon. You can do so in the Tools Roamon menu. Set the Enable checkbox. And it would already work from here. But it's recommended to set at least 2 more settings. That is to set the ID manually. The ID is just identifying the router within the Roamon network. And if you don't set it manually, it will simply pick one of its MAC addresses. And as you probably know, there are virtual MAC addresses, like MAC addresses for bridge interfaces or for VRRP interfaces. That means if it's picking a bridge address and the bridge is deleted, the MAC address could change, and then the Roamon ID would change too. That would lead to bookmarks within Winbox are not valid anymore. A bigger problem would be a virtual address of a VRRP interface, as this address would be the same on 2 devices. And if that happens to be the Roamon ID, you will not be able to access both of the devices by Roamon. So we suggest to just set it manually and pick a physical MAC address as the Roamon ID, like the first Ethernet interface address, for example. Then there's another setting that's the Roamon secret. You don't have to set it, but if you don't, you could accidentally build larger Roamon networks as you plan to. For example, if one of your customers or your internet service provider is also using Mikrotik and is enabling Roamon, and you're not setting the secret, your Roamon network will extend across your own devices, and that's definitely nothing you want. So simply set the secret over there. And there's an optional setting that might not be really necessary. That's to set the ports, what you can do here. And by setting ports, you can disable or enable Roamon on separate interfaces. And in case you have more than one path to another destination, you can also set path costs for the interfaces. So once you enabled Roamon on all the devices in your network that you want to be part of the Roamon network, you can start using dedicated Roamon tools. There's discovery, ping, SSH, and Winbox support. But also, although these tools sound similar than the standard IP or MAC-based tools, they're special and they have to be accessed from the Roamon window here, like discovery and ping. Roamon SSH is only available on the command line interface, and we will see the Winbox integration in a second. Here's an example that demonstrates that MAC ping and Roman ping is not the same tool and is not working the same way. As you can see, you can't MAC ping this MAC address here from a router, and at the very same time you can Roman ping the Roman ID from the same router, as that one is crossing a layer 3 boundary. And here's the integration in Winbox. What you see here at the bottom is the MNDP output, like the discovery output from the operator's laptop in the network I've shown you before. I'll just scroll back a few slides. So we use MNDP from here. We'll see these 3 devices. The 3 devices down here. And then we use the connect to Roman button at figure 2. And once you're connected to the Roman network of that router, you can see in figure 3 that you're using a Roman agent now. So everything Winbox is showing you from now on is not the view of the laptop, but is the view of the Roman agent number 3. And that one can see all the devices in the complete network, as you see here. And over there is a Roman ID, which is accessible using 2 hops. So you can clearly see that we are crossing a layer 2 boundary over here. And that's what's happening. At the bottom, you can see the same line from Winbox, the 2 hops. The operator is connecting to the Roman agent, and the Roman agent is using 2 hops to access the access point at the end of the network. So that way, the operator can access all the devices within the complete local network. Why Roman is really useful in a local network, it's even more interesting if you use IP to connect to a Roman agent. That is, you can use a remote Roman agent, for example, at a branch office or at your customer's network. And if you do that, you can access all the devices in the remote network by Roman, as I just showed you in the local network. And here's an example for that. So no matter where your customers are, if you have internet connection to their Mikrotik gateway, and if Roman is enabled in the customer's network, you can connect to that router by IP. And from here you will have access to the complete devices of his network. If you use such a setup, you should definitely take care that you're disabling Roman on the WAN interface so that you're not extending your Roman network to your ISP. And it would also be a very good idea to disable Winbox access on the WAN port, as there's been quite a few ugly hacks using publicly accessible Winbox ports. So it would be a good idea to combine Roman with what we've heard before, the separation of management and payload. That is, build a VPN to your customer's gateway router, use Roman through the VPN tunnel. Then you can disable Roman on the WAN interface, you can disable Winbox on the WAN interface. And if you want to, you can also limit Roman locally to VLAN interfaces, so you can set up a dedicated management VLAN across your network and combine the best of all 3 possibilities. So far for Roman. The next thing I want to show you is how to integrate third-party management tools, or how third-party vendors are able to integrate their management tools by using basic RouterOS features like CLI features and scripting in this example. The tool I want to show you is called HSNM. It's actually a commercial captive portal solution, but it offers very tight Mikrotik integration, so it's an interesting example on management through third-party tools. I don't want to talk about the features of the captive portal itself, but we'll just focus on its management and monitoring capabilities. The features of RouterOS that are being used by HSNM are just import, scripting, and the script scheduler. Oops. think I have to check for my power supply. What you don't see is the 6% warning on my laptop here. There are two concepts that I just want to explain to make the next slides understandable. Within HSNM, a gateway is a Mikrotik hotspot. It could also be the WAN gateway, but it's simply called gateway within that software solution. And an access point is just an access point. It could be Mikrotik, it could also be a third-party access point. So let's have a look on how to integrate a Mikrotik hotspot into this captive portal solution. All you have to do is to use the context menu, add a gateway, and on the configuring page of the gateway you can already see Mikrotik specific parts like the hardware type or the RouterOS version. Once HSNM knows that you're configuring a Mikrotik gateway, it will offer you many Mikrotik related aspects. For example, configuration of the WAN interface, configuration of authentication by MAC address, which will be a setting in the Mikrotik hotspot, or on the other page you can see the hotspot settings, which interfaces should be part of the hotspot bridge, and so on. So all these Mikrotik related settings can be made in the user interface of HSNM. And if you're done, or when you're done, you can download a configuration file, which is simply an RSC file, upload that to your Mikrotik router, and use the /import facility to configure the complete router. So you don't have to do any configuration in Winbox at all. After you did that, you have the initial configuration, and you have a bunch of scripts, a really complex scripting environment. And scripting is definitely one of the advantages that RouterOS is offering. And we'll see how scripting lets you integrate your Mikrotik gateway into this management solution. There are actually 4 parts or 4 different topics that are being addressed by scripts. Updating Mikrotik's configuration. So if you change configuration details in the captive portal, these are transferred to the Mikrotik router, or not transferred, these are fetched by the script, and the RSC file is installed. Then there's the possibility to import data from the captive portal, to export data to the captive portal, and to use monitoring capabilities. Importing can be interesting to keep a central walled garden list, for example. Imagine you have multiple hotspot systems belonging to one huge installation. If you configure your routers one by one, you have to take care that the walled garden list is synchronized between all routers. And here in HSNM, you can configure the walled garden not on gateway level, but on domain level. You see sample entries here. And the scripting host is running a script regularly to fetch the walled garden list and to install it in all of the gateways. Then here's an example how exporting data from the hotspot to the central captive portal could be interesting. Actually, there are quite a few solutions around that use User Manager. In figure 1, for example, we see a Mikrotik compatible ticket printer. These ticket printers pretty often print a ticket and then they create an account on the local user manager on the hotspot gateway. And there are also quite a few third-party applications that are using User Manager instead of a radio server. So if you want to integrate such a legacy solution into a larger management tool like HSNM, you need a possibility to do that, and the export script that is part of the system will automatically take user manager users, move them to the radio server in HSNM, and delete these users on the gateways. So you can continue to use legacy development or legacy hotspot printers as you used them before. Then there's another possibility on what exporting data could be useful. In this case, we see GPS-based maps and tracking of gateways. The script based on your RouterOS hotspot will automatically send GPS data to the HSNM system, and you can keep data for a certain amount of time. That way you can create tracks of your gateway. For example, if they're installed in a bus or in a train or a taxi, you can create an automatic map showing you where the gateway is moving along. Or if you're using static GPS locations, so if your Mikrotik device doesn't support GPS data, you can create visualizations of gateway locations. Here's, for example, here's an example of a dynamically created map for a bus. Here you can see the track of the bus, and the GPS data is drawn from the Mikrotik router. This is an example for static GPS data just entered into HSNM. You can see 2 gateways over here, 3 over there. You can zoom in the map. You will get all this functionality that you might know from third-party or from different vendors' controllers. And we see Mikrotik customers asking for such graphical representations quite often. And there's also a third possibility of visualization, that's real floor plans and maps. On this map here, you don't just have the blue dot, the gateway, but you can also see access points. And these access points will also show coverage with green and red circles. This here, for example, is our premises with access points in the training facility, in the offices. You can create such maps dynamically, or you can use floor plans and really upload plans of buildings. You can have multiple stories, as you can see here, floor 1 and floor 2. And you can create representations, as I said, of gateways and access points. And the devices will also give you a direct way to open the management interface of the given hotspot or the given access point. So here you can see Mikrotik's web interface within HSNM. So you have the possibility to exchange data in both ways, have dynamic maps, and access the management interfaces of your devices automatically. There's actually a lot more, like availability and latency. That is, you can see if devices are online or not. You will see all captive portal related values like bandwidth, amount of data transferred, and so on. But that would be well beyond the scope of the presentation today. Actually, I'll shorten this a bit, so you'll have some lunch at least. You can see the slides for AP integration in the wiki or in the download. Just skip this here. What we've seen in the presentation before is packet sniffing already, but there's one very interesting part that I want to add, and that is that Mikrotik is offering a packet sniffer within RouterOS. And you can also sniff into a file on your router, but there is one pretty special and useful thing, that is you can send sniff streams directly from your router to Wireshark. Wireshark is the de facto standard for packet sniffing, and you can do that live. So streaming to Wireshark means if your router on your customer site can access the operator's notebook, you're able to configure that router to send packets live to Wireshark on that notebook. What you have to do is all be done in the packet sniffer menu in figure 1. You can see that you have to give the service IP, that is the notebook that is running Wireshark. It's pretty important to check filter stream, because if you're not filtering the stream, the packets of the stream will be sent back into the stream, and then you will create an infinite loop and max out the CPU of your device within 10 seconds. So make sure you filter the stream. And in Wireshark, you have to take care that you're only looking at the packets that are being sent by the TZSP stream. That one is running on UDP port 37008. So here's the filter in figure 2 that you have to configure in Wireshark. And if you do so, Wireshark will give you a live representation of the packets captured by your router anywhere on the world. If you have a look at Wireshark, you can see at figure 1, it's only showing you the filtered packets, and it's live. Here at the bottom you can see it's a live capture. So this is a very useful feature. Traffic flow is another pretty interesting feature integrated in your Mikrotik router for network debugging. While packet sniffing is real low level, so if you're having complicated problems to debug, you want to go to the packet sniffer and look for separate bytes. Traffic flow is the other end. It will gather statistical information and is compatible with NetFlow. And NetFlow will answer questions like who are the top talkers in my network, what are the top protocols, or what is the utilization. These are questions that you cannot answer by other means. For example, if you use syslog or use SNMP, it will be very difficult to find out who the top talkers in your network are. You can have a look at the configuration later on. There used to be a de facto standard called NTOP as a collector for NetFlow. NTOP is still available, it's an open source tool, but its successor is called NTOP-NG, and NTOP-NG isn't offering free support for NetFlow probes anymore. So with NTOP-NG, you have to buy a commercial probe called nprobe. There are different free solutions around, and we integrated one in our own management platform. And here you can see some sample output for NetFlow analysis. Down here, for example, you can see port 53 has been used 40%. Here are top talker statistics. Here are top protocol statistics. This is all information that you cannot get conveniently by any other mean but by NetFlow. So there's 4 more minutes. At 1 o'clock I'll leave you for lunch. I think one of the most underestimated features on your router is its local log. Its local log file is what you need to debug all events on your router. But local logging is usually not sufficient if you're talking about a network. Just imagine this simple VRRP setup over here. If you want to debug a VRRP state changing, you have to look at all parts of the VRRP cluster. You have to look at the complete layer 2 network between the cluster devices to understand why one of the devices changed its state. So local logging is simply not enough. So you will definitely, or you should definitely look into a central syslog server. Log files will survive reboots. They are tamper-proof, so if the router has been hacked, the log cannot be deleted anymore. You have better search capabilities, and what I just explained, you can correlate events across devices. You can set up remote logging pretty easily in the Mikrotik logging facility by use the logging type remote and name a remote syslog server. And here is an example dashboard of our management tool, which is only using syslog data from the routers of a complete network. What you can see here are Wi-Fi connections across the time and across routers. And again, this is nothing that you can get from SNMP. From SNMP, you can get the number of simultaneous Wi-Fi connections. That's not a problem to get by SNMP OID. But if you want to know how many connections really took place, for example, if there's a flapping of clients, then you have to look in your local log files. And this is just drawn from syslog over here. So you can see 91% of all connection attempts in the complete network are happening on one single IP address. So it's probably worth to check this address if the router or if the access point has a problem. And if you extend a central syslog facility, if you make it really understand Mikrotik's logging syntax, like you see here, then you can get even more interesting information. At figure 1, you can see a log message for a failed login attempt on your router. And this log messages contain two important informations. Who or which username was used, which facility, and which IP address. The IP address is part of the syslog message anyway, so you can go ahead and extract the username and extract the facility. And if you make your central syslog server understand Mikrotik's logging syntax and use separate database columns, as we do here, to save these values, then you can create drill downs or dashboards that you can't get on any other way. And this is the last slide. So what you see here is a drill down of our central syslog server with enhanced understanding of Mikrotik's syslogging format. And you can see over here just the number of failed logins. This is actually just counting log messages. But over here you can see a drill down of the usernames being used and the login facilities being used. I'll zoom in a little bit. So you can see 40% of the failed logins used the username admin and 32% of the failed logins used SSH. It might not seem very useful at that point, but it's just an example on how powerful central syslogging with enhanced understanding of Mikrotik's logging format is. And you can create far more useful dashboards if you're combining this with SNMP and NetFlow output on the same dashboard. So, well, I'm 1 minute late. Thank you well. I hope you enjoyed it, although I rushed you through.